So my name is Patrick Morris, and I'm in Berlin. And this is not my problem, it's a problem of the following authors. In a paper from last year, and so this was suggested to me by Alexei Pokrovsky. So the problem is about domination in digraphs. So you have some digraph D, and the domination number, which is the natural definition, so the smallest size of a dominating set, where a dominating set is, so if you have your digraph, a set S is dominating if either, so every vertex is either in the set itself, or there is a directed edge from the set to the vertex. Okay? And so not much is known, as far as I know, about dominating sets in digraphs, and the question is, what can we bound these by? So in the normal graph case, you have a very simple bound, which is just the independence number. If you take a maximal independent set, this is obviously dominating. This doesn't hold for digraphs, but can we hope for something in terms of the independence number? So the original question is something like, does there exist a function such that this domination number is less than a function of the independence number of D? And the answer is no. So in particular, if you take a random tournament, then you get that the independence number is obviously 1, but the domination number is of the order of log n. Okay, so what if we put extra restrictions on the digraph? So for example, it's not very hard to show that if it's acyclic, then we recover this bound in terms of, so the independence number itself is a bound on the domination number. So here acyclic, I mean no directed cycles. So it's you're allowed cycles in the underlying graph, but not ones which follow the orientation. And right, so what these guys did was look at what if we loosen this condition and just require that there's no free cycle, so no triangle orientated round. Can everyone see this, by the way? Is it going? Ah, yeah. So if you have no directed free cycle, then we do have a bound, but the bound that they got was alpha times alpha factorial, and their conjecture is that in this case, we should be able to get a polynomial bound. Okay, any questions? Alpha times alpha factorial is what they got, yeah. Yeah, so they didn't mention anything about this, and I also haven't really thought about this, but that could also be interesting. It's, yeah. I think it's unlikely that it's something this large, but yeah. So it's only really interesting for independence number very small. If your independence number gets large, then you can easily show, large in terms of the number of vertices, then you can easily show a polynomial bound. But for very, for very dense graphs, it's interesting.